The sun's light travels across space to the planets like ours. We can measure its huge speed, and when it arrives at Earth, then interactions begin. Firstly, of course, with our atmosphere. There's scattering by molecules and by much bigger ice crystals and fine droplets of water on a misty morning. Interactions with plant life capture the energy of sunlight, so that a vast complexity of life has developed. So, let the sun shine in. We recognize the importance of the sun, and people have carved stone to share its image, as in the sunstone created by the Aztec civilization in Mexico about 600 years ago. A present-day Mongolian oval celebrates the blue sky and the brilliant sun. In Nepal, another stone representation, also several hundred years old, of the Hindu god of the sun, Surya, as a halo, a circle of light. The same idea, but with painting, enhanced by gold, elevates characters in Christian iconography. People could never fail to notice beams of light apparently radiating from the sun in a misty sky. The straight lines of travel are clear to see. But for a long time there was uncertainty about whether vision was caused by light that originated inside ourselves, or whether light arrived at our eyes from a world outside ourselves. Ibn al-Haytham lived and worked in Cairo 1,000 years ago, and can be counted as one of the first to base ideas primarily on observation, performing experiments to explore the working of the world. He also used the idea of rays, thin lines drawn to show the direction of travel of light. Through observations, it became apparent that we see light when it enters our eyes, not when it leaves. It does seem unlikely that we could all watch the same images on a cinema screen if vision happens because of emission from the eyes of each one of us. Al-Haytham's great work, the Book of Optics, was later, much later, translated into Latin and became a huge influence on the development of observational science in Europe. Perhaps it was the influence of such ideas about light, inherited after 400 years from Al-Haytham, that produced a representation of light traveling from the sun to the Virgin Mary in the painting of the Annunciation by Fra Angelico in around 1426. Now we can see thin laser beams in smoky air, not quite super thin rays, but close, and they behave as Al-Haytham predicted they would. One of the topics that Al-Haytham explored was refraction, change in the travel of light at boundaries between materials, such as air and glass. Rays allow us to predict and understand pathways of light through optical systems such as our eyes, with or without extra lenses added on the outside. Maths is unavoidable in life and is important in applying ideas about optics to help us to see the world more clearly. By shining bright light into the eye, it is possible, for one thing, to see the retina more clearly, to check for problems. That great source, the sun, seems to track daily across the sky, though centuries of observational science have taught us that it is our own movement, the daily spin of our planet, that easily fools us into thinking that it is the sun that moves. Our motion surely but steadily shifts sunshine and shadow. We can even use shadows as they move to indicate the time of day. And so, every evening we lose the sun, as the daylight moves ever westwards, requiring north-south bands of the Earth to set their clocks to different times. As we spin through the night, time-lapse photography shows that stars also seem to move across the sky.